Lesson 7-6, solving open sentences involving absolute value. In this lesson, you learn to solve open sentences involving absolute value and graph the solutions. Why is it important? Because you can use open sentences to solve problems involving space exploration, law enforcement, and entertainment. So let's take a look at an example in space exploration. On Tuesday, February 7, 1995, the Space Shuttle Discovery maneuvered within 37 feet of the Russian space station Mir, 245 miles above the Earth. To accomplish this feat, Discovery had to be launched within 2.5 minutes of a designated time, 12:45 a.m. This time period is known as the launch window. If T represents the time elapsed since the launch countdown began, and there were 300 minutes scheduled from the beginning of the countdown to blast off, you can write the following inequality to represent the launch window. So the following inequality would be the absolute value of 300 minus t less than or equal to 2.5. So that means the difference between 300 minutes and the actual time elapsed since the countdown began must be less than or equal to 2.5 minutes. Okay? So in this case, we use absolute value because 300 minus t cannot be negative. So when you talk about time, there's no such thing as negative time. And that's the reason why we use absolute value in this case. And if you look at this one, this is a good example of an inequality, absolute value inequality problem. And there are three types of open sentences that involve absolute value. They are as follows: when n is non-negative, simply saying when n is positive, or when n is equal to 0. So the first type, we will be discussing each and every type. The first type would be, okay, I did that already. The absolute value of x is equal to n. That's the first type. The second type will be the absolute value of x is less than n. And the last type would be the absolute value of x greater than n. So let's first consider the first one. The absolute value of x is equal to n. Remember the meaning of absolute value at the beginning, okay, and the early part. The absolute value of a number is the distance of a number from 0. So remember when we talked about the absolute value of 4, absolute value of 4 is 4. Absolute value of negative 4 is 4 because that is a distance from 0. So if you look at the number 4 and negative 4, okay, it is 4 units from 0. Okay, so let's see why that is the case. So if x is, okay, that was my example. Let me take that out, and let me take that out, and then let's look at the meaning of this. So if the absolute value of x is 4, this means that the difference from 0 to x is 4 units. So that's what it means. Absolute value of x, okay, means that the difference from 0 to x is 4 units. Okay, so that means if I'm going to graph this, okay, you have 0, the distance will be 4 units, the distance will be 4 units, and you can see there are two values of x, okay, which will fit into this sentence, okay. So therefore, you see, if absolute value of x is equal to 4, then x is equal to negative 4, or x equals 4. So the solution set is negative 4 and 4. So if the absolute value of x is equal to n, then x is equal to negative n, or x is equal to n. Those are the two possible scenarios, and that's exactly what we have here. That's pretty straightforward. Okay, now what if we are not looking at 0? Okay, remember when you talk about the absolute value of x, okay, you're basically saying the distance of x from 0 is 4. So that means the distance of x from 0 will be 4. Okay, that's what it means right there. We just did not write out minus 0 because it's simply useless to write minus 0. Okay, But let's take a look at the example number 1. Okay. Before we do that, equations involving absolute value can be solved by graphing them on a number line or by writing them as a compound sentence and then solving it. Okay, let's see method number 1, and that means we need to graph it. So we want to find out the absolute value of x minus 3 equals 5. Okay, so x minus 3, the absolute value of x minus 3 equals 5 means the distance between x and 3 is 5 units. Just like what we discuss here, this is the meaning of absolute value of x is the absolute value of x minus 0 equals 4, meaning, okay, the difference between x and 0 will be 4 units. Okay, and that's the reason why we start with 4, because of the that's the reason why we reckon, or we start with 0, okay, and then we move 4 units to the right and 4 units to the left. So following that same example, take a look at method 1. It means the distance between x and 3 is 5 units. So to find x on the number line, start at 3 and move 5 units in either direction. So we get this. We start from 3 and we move 5 units to the right and 5 units to the left of 3, and we get these two numbers, -2 and 8. So the solution set is -2 and 8. Okay? And that's how you find the solution, by using a graph. Let's take a look at method 2 and see how that works. And this time we are going to use a compound sentence. Okay? So when you talk about the absolute value of x minus 3 equals 5, it also means x minus 3 equals 5, or negative x minus 3 equals 5. Okay? Very similar to this scenario right here. Okay? So you have x minus 3 equals 5, or the negative x minus 3 equals 5. Those are the two possibilities of the absolute value of x minus 3. Okay? So let's take a look at this one. So this one means x minus 3 equals 5. We can solve this easily for x. We simply add 3 to both sides. We end up with x equals 8. Okay? And let's take a look at this scenario right here. You have the negative quantity x minus 3 equals 5. If you distribute the negative sign, this will become, not distribute the negative sign. If you multiply each side by -1, okay, you'll notice that this will simply become x minus 3, and this will become -5. And then you simply add 3 to both sides. You end up with x equals -2. And if you notice, the solution set is the same. Okay, so this verifies the solution set. So method 1 involves graphing the absolute value. Method 2 simply involves a compound sentence. Okay, let's take a look at the next scenario. The next scenario will involve the case of the absolute value of x less than n. Inequalities involving absolute value can also be represented on a number line or as a compound inequalities. Let's examine the absolute value of x less than 4. Okay, so in the first scenario, we have the absolute value of x less than equal to 4. This time it's going to be less than 4. What does that mean? So it simply means that when you say the absolute value of x is less than 4, okay, it means that the distance from 0 to x is less than 4 units. Remember, when it was the absolute value of x is equal to 4, the distance between 0 to x is equal to 4 units. So in this case, it is less than 4 units. Okay, so what do? We again, okay, we start with 0, okay, and from 0 we go 4 units to the right and 4 units to the left. Okay, now why is it an open dot? It is an open dot because 4 is not included in our solution. And at the same time, why is there a line in between? Because all the values that are on that line, okay, will be the values of less than 4, okay, meaning less than 4 units from 0. So all these points right here, okay, all the points indicated on the line, okay, are values that would indicate that they are less than 4 units from 0. Okay? So therefore, x is greater than negative 4. Okay? So x is greater than negative 4 because it's going to the right, and x is less than 4. So the solution set is x such that x is greater than negative 4 and less than 4. So if the absolute value of x is less than n, then x is greater than negative n, and x is less than n. Okay? Does that make sense? Okay, if not, repeat that again for your own understanding. Okay? And let's take a look at example number 1. We want to solve the absolute value of 3 plus 2x, okay, less than 11, and graph the solution set. So in this case, the absolute value of 3 plus 2x less than 11 means that 3 plus 2x is less than 11 and 3 plus 2x is greater than negative 11. What happened here? Okay, don't panic. You have 3 plus 2x. Remember what we talked about. If it's the absolute value of x, there are two things that can happen. This can be an n, or this can be an negative n, what we talked about, right? So in this case, if you have that, okay, if you now have the absolute value of 3 plus 2x, okay, it will mean 3 plus 2x and negative 3 plus 2x. Okay? Now, why is this still 3 plus 2x? Because in this case, you have equal to less than 11. So what happened here was that you have 3 plus 2x less than 11. That's fine right there. This one is where we need to make changes, because negative 3 plus 2x less than 11. And if we multiply both sides by negative 1, remember when you multiply both sides by negative 1, you switch the inequality. So you have 3 plus 2x is greater than negative 11. You multiply both sides by negative 1 and you switch the inequality. Okay? Or you reverse the inequality symbol. Okay? So let's consider absolute value of 3x plus 2 less than 11, and let's consider the first one. 3x plus 2x is less than 11. Okay, so 3x plus 2x less than 11, and we want to solve for x. We subtract 3 to both sides. Okay, and we end up with 2x is less than 8, and divide both sides by 2. You have x is less than 4. Okay, the next one, let's consider 3x plus 2x is greater than 11. And remember, we talked about how this is negative 11 because of this particular reason, okay, that I gave you. So 3x plus 2x is greater than negative 11. Okay, we subtract 3 to both sides. You end up with 2x is greater than negative 14. Divide both sides by 2. You end up with x is greater than negative 7. So the solution set is x such that x is greater than negative 7 and x is less than 7, which can be written as a compound inequality, x such that x is greater than negative 7 and less than 4. If you notice, I emphasize the word and, which means, if you remember in the last lesson, the word and represents intersection. So if we graph this, this is how we graph the solution set. We have an open dot on negative 7 and an open dot on 4, and we simply connect it with a line. So one big tip that I can give you right here, right now, okay, this is not in the book, so I suggest you write this down. If you have any absolute value that involves a less than sign, okay, or a less than or equal to sign, it will involve a graph, okay, which will involve the word end, and it will involve a graph wherein you need to have a shaded or a solid dot, and there's going to be a line in between. This is how your graph would look like in inequalities such as this one. Okay? Let's consider the third case of this. Let's examine absolute value of x is greater than 4. This means that the distance from 0 to x now is greater than 4 units. Remember, when it was equal to 4, the distance between 0 to 4 is equal to 4 units. When it's less than 4, the distance between 0 to 4 is less than 4 units. And now, since it's greater than 4, the distance from 0 to, not 0 to 4, I'm sorry, 0 to x is greater than 4 units. So again, we start with 0 and count 4 units to the right of 0, okay? And you'll notice that it's negative 4 again in 4, but this time it's greater than 4, okay? If it's greater than 4, that means you go to the right of 4, okay, and go to the right of, sorry, to the left of negative 4, because those are the units greater than 4, okay? 4 units is negative 4, 4 units is 4, okay? 4 units greater than negative 4 would be to the left, 4 units greater than negative 4 would be to the right, okay? So with the inequality is greater than or equal to, the compound sentence uses the word or, okay? And in this case right here, what we did here, the compound inequality uses the word and, okay? And this, I think, is written on the, I think it's right here. Why did not, okay. So if you look at your book right here on the left side of this, okay, this left side of the page of your book right here, okay, I wasn't able to copy it down. When the inequality is less than or less than equal to, the compound sentence uses and. Okay, so let's go back here. So if we want to solve, okay, the absolute value of 5 plus 2y is greater than or equal to 3 and graph the solution set, okay, what do we want to do? Let's look at the let's look at what's going to happen here. Okay, 5 plus 2y, or the absolute value of 5 plus 2y greater than negative 3 means, okay, that 5 plus 2y is less than or equal to negative 3, or 5 plus 2y is greater than or equal to 3. Again, using this particular sentence. Again, how did we come up with that? It's because if you look at this one, you have the absolute value of 5 plus 2y is greater than or equal to 3. And you have two scenarios to look at. 5 plus 2y is greater than or equal to 3, which is this one right here. And the other one would be the negative of 5 plus 2y is greater than or equal to 3. And then we simply multiply both sides by negative 1. We multiply both sides by negative 1, you have 5 plus 2y. And then the inequality switches. And that's why you get this one right here. Okay? So let's solve both inequalities. Let's do 5 plus 2y greater than or less than or equal to negative 3, this one. So we subtract 5 to both sides. And we end up with 2y less than or equal to negative 8. And divide both sides by 2. End up with y is less than or equal to negative 4. Okay? And let's do 5 plus 2y greater than or equal to 3. We subtract 5 to both sides. End up with 2y greater than or equal to negative 2. Divide both sides by 2. You end up with y is greater than or equal to negative 1. And remember, when you have greater than or equal to, we use the word or. That means in graphing or, you mean a union of both of those graphs. Okay, so you since it's less than or equal to and greater than or equal to, we have two closed circles or closed dots. Okay, and since it's greater than negative 4 or less than or equal to negative 4, the arrow goes to the left. Greater than or equal to -1, the arrow goes to the right. Okay? And let's take a look at the last example. Organizations such as OSHA set standards for buildings to meet the needs of those using the building. Building code standards are often written as maximums or minimums that must be met. These standards can be written as inequalities. So many specifications in the building industry address the needs of physically challenged persons. For example, hallways in hospitals must have handrails. Handrails must be placed within a range of 2 inches from a height of 36 inches. Okay, again, the last sentence gives you a clue that this is an absolute value inequality. So the handrails must be placed within a range of 2 inches from a height of 36 inches. So write an open sentence that involves absolute value to represent the range of acceptable heights for hallway handrails, and find the graph of corresponding compound sentence. So letter A, the open sentence would be, if we let h be the acceptable height for the handrail, then h can differ 36 inches by no more than 2 inches. So, write an open sentence that represents the range of acceptable heights, and that would be, let's translate this first. H differs from 36, that means the distance, okay, or the difference between h and 36, okay. And then when you say less than or equal to, okay, 2 inches by no more than means less than or equal to 2 inches, and this becomes your inequality. And you know that this is a less than or equal to inequality, and the word end is involved here. Okay, that means it is the intersection of both graphs. Okay, so let's look at the two scenarios. Okay, to solve the absolute value of h minus 36 and less than or equal to 2. You have the first one, which is h minus 36 is greater than or equal to -2. Okay, again, we know how to do, we know how we got that -2. We simply multiply both sides by -1, and we simply switch the inequality, that becomes -2. And then we solve for h, add 36 to both sides, end up with h is greater than or equal to 34. And we have h minus 36 is less than or equal to the other case of this one. Okay, and we simply add 36 to both sides to end up with h less than or equal to 38. So the compound sentence is h is greater than or equal to 34 and less than or equal to 38. Okay, and if you graph this inequality, compound inequality, you'll end up with the open dot on 34, on the open dot on 38, and line in between. Remember, this is an end, okay, scenario, which means it's the intersection of both these two graphs. Again, to refresh your memory, again, how we got this. Remember that when we talk about the absolute value of h minus 36 less than or equal to 2, you're talking about two cases here, two scenarios. One is h minus 36 less than or equal to 2, and the other one is the negative h minus 36 less than or equal to 2. Or, if you multiply both sides by -1, you end up with h minus 36 greater than or equal to -2, which is this one right here. Okay? So to summarize, okay, before I give you the secret word, well, you know what, let me give you the secret word right now. The secret word is patriots. Secret word for this lesson would be patriots. To summarize, when you see the inequality less than, okay, x less than or less than or equal to, let's say, a particular number, n, you think of the word end, and you would have a graph that would involve, okay, an open dot or a closed dot, and there is going to be the line in between. Okay, and if you see an absolute value inequality, sorry, I forget an absolute value inequality there. Okay, greater than or equal to n. Okay, you'll think of the word or. Okay, and you'll have a graph now Okay, and this is your n right here, and this is your n right here. You'll have a graph, an open dot or a closed dot going away from each other. Okay? And that's it for this lesson. Thank you for watching.